Good morning, one and done. Next topic will be the system bandwidth. In the system bandwidth, we'll consider the magnitude response. Generally, the magnitude response will be the constant magnitude of the system, which will be specified as our bandwidth. The bandwidth of the system is defined as the range of frequencies over which the bandwidth is mod of h of omega, which contains within the frequency components of the mid band. That is, the bandwidth will be defined as the W2 minus W1. That means we have a particular bandwidth, consider the 1 by root 2 of that particular one, then corresponding frequencies note down, that the corresponding frequencies will be the omega 2 minus omega 1. Therefore, the difference between those two is the bandwidth is equal to omega 2 minus omega 1. That is, when we consider the system bandwidth, let it be given by a particular one, system bandwidth, whose magnitude response, draw a one particular line at the 1 by root 2 where it touches the our constancy graph, indicate the corresponding frequencies as omega 2 and omega 2, and the difference of those two frequencies will be our difference of those two frequencies is the system bandwidth. Let this system bandwidth will be calculated for every system like a distortionless system and amplitude amplifiers like class A, class B, and frequency response. While calculating the frequency response, we can calculate the bandwidth of the system. System is said to be causal if it does not produce the output before the input is been applied. Therefore, the system is said to be satisfied if its impulse response must be 0 before the input is been applied. Generally, the input will be applied at t is equal to 0. Therefore, before that means the t less than 0, the output should be 0. That is, h of t equal to 0 for t less than 0. It is being called as the condition for the time domain. Therefore, for condition in the frequency domain, the criteria implies that the necessary and the sufficient condition for the criteria to be in the frequency domain will be given as minus infinity to infinity ln of mod of h of omega by 1 plus omega square d omega less than infinity. Therefore, the magnitude function is said to be the square integral before the polynomial criteria is to be valid. That means to implement that particular criteria, the first we need to check for this particular condition from minus infinity to infinity mod of h of omega whole square d omega less than infinity. This is the condition for checking the polynomial criteria for the physical realizability of the Airy system in the frequency domain. For checking in the time domain, the equation has been given as, that is, h of t will be equal to 0 for t less than 0. When it is been 0 for t less than 0, the system is said to be causal and it is been physically realizable. When the h of t not equal to 0 for t less than 0, it is non-causal, hence it is not physically realizable. This is the condition for checking in the time domain. And the condition for checking in the frequency domain will be given like this. That's minus infinity to infinity ln of mod of h of omega whole square by 1 plus omega square d omega less than infinity. And the magnitude function is to be square integral before the polynomial criteria. Before the polynomial criteria has been satisfied.